Hi everyone, I'm Trishu, second year PhD student, working with Dr. Amy Jacobson. And my research is on constraining the onset of OAE1A by using the novel calcium and strontium multiproxy. So basically, OAE1A is back in the time period. Well, for this event, it's 120 million years ago. And back in the day, there were no oxygen in water, and then there's like a rich organic matter deposit worldwide. So my research is on like what's the cause and consequence of the event. So based on a previous lab member, Chuyan, so his research is on the entire event, as you can see here, and then we see this little dip in calcium isotopes. So my research is more like on this little dip and trying to zoom in, and then I have 30 samples instead of covering the entire event. I'm mostly on the pre-event and then trying to zoom in this area. So I have two sets of samples, 30 each. One is with one is from the DSCP core 463, as you can see, it's right here near Hawaii. And then the other set is from a French core that Katja and our collaborator had. So I'm trying to correlate the three sets of samples. One is from Chuyan sample, and then the DSCP 463, and then the French core, because they have different depositional environments and history. So we want to see what's going on there. So for this summer, I worked as a new geopath mentor, and then also an online peer mentor for the NU English language program. So I have so I mentor a lot of incoming international students. It really reminds me of me back in the day. And then for research, I submit the sample request and then it got approved. And then most of the time I spend in lab and then do sample preparations for both cores. So I move from dissolving sample, filtering them to all the other procedures until I can get the data at the end. It usually takes like days to get just one data point, and it might not even be good enough. So I'm still in the process, but now I already processed 30 samples for calcium and then 10 for strontium. They go through columns and everything. And then I learned how to do data reduction with the help of Anna, and then other trainings, and then last thing. So here are a couple pictures. So this is what it looks like for a standard TIMS run. You can see we got signals. So the machine measures 120 times of the same samples. And then yeah, that's about it. And then lab cleaning, and then this is what I did for strontium polymers. That's about it. Yeah.
Great talk. Do you have any hypotheses about what the drivers for the event could be, or how they'll test it?
I think for now we're thinking about a volcanic trigger for the event, and then maybe we can correlate that with the oxygen and carbon isotope data, and then maybe like draw a full picture.
I know calcium's pretty new. Has anybody else done calcium on the 1A event? And if they have, do you also see that little blur before the 1A event for calcium?
I think just Juyan's paper.
Just his paper, okay.
Yeah.